We're going to do another worked example because each of these trig graph worked examples will have a different trick that's really helpful for us. And so we've been given a cos 2x graph, so a cos graph that happens twice as often as it should. So the period would, instead of being 360, we divide it by 2, so the period's 180. The interval's changed, but that's not the end of the world. It's just from minus 270 to 90. So if I was using the calculator method to draw this graph, this would just be my starting point, minus 270, and this is what I'd put in for my end. And so you can look at my other video on how to draw graphs using shift table and then typing in the graph. For this example, I'm just going to dive straight in. So I've punched this gx into my graph. It's given me my coordinates, and they are minus 270 and 1, 180 and minus 1, 90 and minus 90 and minus 3, 0 and minus 1, and then back up to 90 and 1. And so you've got a graph that looks roughly like this. Then they have this left field question: let A be the point of intersection of f and g. Show the x coordinate of A satisfies the equation sine x equals minus 1 plus root 5 over 2. So let's just say this is A. There is also another point that I could have made A here. So I see 2 points intersection. Now, for starters, this, I think if you saw this in the middle of exam, you'd have some heart palpitations going on. I'm just going to get you into my head just to tell you how I would approach this. So point of intersection, before I'm panicking about this, I'm just going to make the one graph equal to the other graph. This would be difficult for grade 11 to do, but for grade 12s, you would notice this is a double angle. And so you've got three options. Which is the best one? Well, because you're dealing with sine, the best option that you could choose would be the graph that has to do with sine x. And so I'm going to cleverly choose that option, 1 minus 2 sine squared x. And the minute that I've chosen wisely, I notice that this starts to look a bit more like a trinomial. I personally like the squared term to be positive, so I'm going to take this across. And this doesn't become 0, it becomes minus 2. Everything has a 2 in it, so it's probably easier just to divide everything by 2. So we'll have sine squared x plus sine x minus 1. Now at this point you can try factorize it, it's a trinomial, or you can just think of this as a trinomial that you can't factorize and then do it with the quadratic formula. And so if it helped you, you could just think of this as being k. So if you literally wrote k, you'd have to just say let sine x equal k, and then you could carry on factorizing from there. So I use the quadratic formula, and what it gives me, and instead of saying x equals in the quadratic formula, I would say sine x equals, I end up with an answer of this. I haven't shown all the working out, but I basically just used the quadratic formula. Or this one that I've just written doesn't work out because you end up with an answer that's smaller than minus 1, and you can't have sine equaling smaller than minus 1 or bigger than 1. So your calculator, if you shifted here, would have probably given you maths error. So this one is no solution. This is the one we're going to work with, and that's what they wanted. And so that's perfect. So now we know that's what sine x equals to. If I need the actual coordinates of the point of intersection, I can just treat this like I would a general solution, which is quite common for trig graph related questions. And so if I punch this into my calculator, shift sine of this, sine is positive, so it's the first and second quadrant. And my reference angle that I get, I always like doing these two steps when I do general solution, tick the quadrants and get the reference angle, and it ends up being 38.17. And so to get into the first quadrant, I've got x equals 38.17 plus k360, and I'm always just going to, as a discipline, write k as an element of the integer. Or to get in the second quadrant, it's 180 minus 38.17 plus k360, and that gives me 141.83. And so there are my two general solutions, and if I want the specific solutions, I'll say, is that 38 inside the region? And that looks bang on 38. Is 141 somewhere in this domain? And it's not, it's somewhere over here. And so all I do is I minus 360 from 141, and that should give me this value. And when I punch it in my calculator, I end up getting minus 218.17. And so here I've now got my two x values. And like a normal graph, what do you do if you're missing a letter? What do you do if you're needing the y? You just sub it in. So you can sub 38.17 and the minus 218 into the original graph, whichever one looked easier for you, and that spits out the y value, which is 0.24 for both of them. And so there you've answered question 6.3. You've worked out the coordinates of the point intersection. So that was a great question for some really juicy stuff. I hope that you found it useful. If you did, please like this video, subscribe to our channel, and share it with your friends. Thanks.